Okay, so this problem is about recognizing what's in front of us. We're going to try to find this, which angle are we talking about here? This is the Greek theta, and we're thinking about what angle does that represent? Okay, well, to clear this up, let's add square root of 3 to both sides, because we'd kind of like to get this all by itself. So we're going to say square root of 3 on both sides, so we have 3 times the tangent of theta is equal to the square root of 3, since we added it to both sides. And then again, we want the tangent alone, so we're going to divide by 3, so the 3's cancel. But then I have to divide by 3 over here as well. And so we have the tangent of theta is equal to the square root of 3 over 3. And at this point, we're going to start thinking about, okay, I want a reference triangle with the square root of 3 and 3 in it. And you say, well, I don't have a reference triangle with those. I know I have a reference triangle with the square root of 3, but I can't recall one that has the 3 in it, and the square root of 3 at the same time. I don't have those. So what we have to do is we kind of have to think backwards. Once you see this the first time, I think you'll see it more easily after this. But what we're going to do is say, if it had been like this, we kind of have to think backwards. I'm sorry about that. We say the tangent of theta. You know how we don't like to have a radical down here? What if that used to be a radical? What if there was a square root of 3 on the bottom, and we multiplied the top by the square root of 3 and the bottom by the square root of 3? There must have been a 1 up here. Now, if you can picture back in what we must have done here, you would say, at some point we said, times the square root of 3 and times the square root of 3, and we ended up with the square root of 3 over 3, just like up above. But it's so much nicer to think about, what we had before. So we're going to go back to this version, and that very much fits in with our thinking about a reference triangle. And I hope that the one that comes to mind is like this, where you have 60, and you have 30, and you have 90, and your hypotenuse is 2, and the bottom is 1, and the side over here, the height is square root of 3. And now you're thinking about, okay, the tangent, if I think about SOHCAHTOA, I'm just thinking about TOA, the SOHCAHTOA part right here, TOA. I'm thinking about the opposite over the adjacent. So what angle has 1 as the opposite and the adjacent square root of 3? Well, that would be this 30 here. The opposite is over here at 1, and the next door neighbor, the adjacent, is over here at square root of 3. So what I say here is that we're thinking about theta as being 30 degrees here. Now, here's the thing. When you think about tangent, remember this. Tangent the tangent of theta is equal to the sine of theta over the cosine of theta. And we've been talking about the fact that sine has a lot to do with y, and cosine has a lot to do with x. And if you notice here, this is a plus 1 and a plus square root of 3, so they're both plus. So we're thinking about plus y's and plus x's. So when we think about this in the coordinate plane, plus y's and plus x's, that's over here, quadrant 1, where everything's positive. So of course I can draw 30 where everything's positive. Of course, there's my 30 degrees right there. So theta is equal to 30. I'm off to a great start, but I'm going to leave space for another one because there's something else that meets the qualifications. But you have to think about the fact that if you had a minus y over a minus x, that would also be the same thing as a plus y over, because these would cancel. If you have negative divided by negative, you end up with a positive. So where are they both negative? Well, they're both negative down here in quadrant 3. So if I had a 30 down here, if I had 30 degrees down here, that would also qualify as and so you think, what's 30 past 180? If you go around like this, here's 180, and then you go another 30. 180 plus 30 is 210. So 210 would also qualify as good for our theta, because when you go over here, let's change colors. Let's see if I can change colors, maybe. Nah, that might be beyond my pale. Okay, here we go. if we had this triangle set up, we'd have a -1 going here in the x direction, and we'd have a negative y going down here in the y direction, but they'd cancel out because negative over negative is a positive. So either one of these would work. And of course, I want to always answer the idea that if somebody says, what if I go all the way around and come back up here on 30, that would be 360 plus 30, that'd be 390. But I'd say, well, we're limited to stop at 360 there. We have to be less than 360. So we'll stop with these two answers, 30 and 210. Okay.